Hi everyone, in this video we have to learn about the arithmetic pipelining. In the previous video we have to learn what is the pipelining and what is the definition of pipelining. Here we discuss about arithmetic pipelining in a detailed manner. First we have to go to the definition. It is the dividing an arithmetic operation into a sub operations and allow each sub operation to execute in the execute in a dedicated segment. Here only one difference. In the previous video, in the pipelining definition we use only a process, but here the process is arithmetic operation, so that arithmetic operation can be divided into sub operations and allow each sub operation into can be executed in a dedicated segment using a dedicated segment. Here dedicated segment is hardware unit. The entire definition tells only one thing, that is the arithmetic operation can be divided into n number of sub operation. That n number of sub operation can be performed in a dedicated segment, that is hardware component. Now what is the advantage of the pipelining process? Arithmetic pipelining process is to add the two floating point numbers or subtract the two floating point numbers. For adding and subtracting the two floating point numbers, we have to use the arithmetic pipelining process. Here I will take the examples. A is equal to 0.9504 into 10 cube and B is equal to 0.820010 square. Here these two are exponents and these two are called mantisas. Here floating point numbers have the two parts. One is mantissa, other part is exponent part. So this part is mantissa part, this part is exponents part. In order to achieve the complete knowledge on arithmetic pipeline, we should show one flowchart and we discuss it in a brief manner. Let us see that flowchart. Let us see that flowchart in a detailed manner. First we have to store the exponent values a and b into a register. Next we have to compare the exponents by subtraction. In the previous example I have the exponent value 3 and 2, there is a difference. So if is there any difference, then we have to go to the this way. After that we have to store the mantisas values into a register. Is there any difference, we have to align the mantisas. After aligning the mantisas we have to store into a register. After that we have to add or separate the mantisas and store it in the R. So normalize the result. What is normalization of a result? If I have the values 1.2 into 10 cube, here or before decimal point will not contain 1 according to the normalization process. So we have to remove that 0.12 into 10 power of 4. This is the normalization result. This should be assigned to the adjust the exponent. Okay. If is there any no difference, then we go to the register R and choose the exponent and choose the and store in the R. Next adjust the exponent and store into the R. This is the flowchart for adding or subtracting the two floating point numbers.